So I would say most welcome to everyone. This is a webinar session from Index. We are located in the Emirates and we are doing EX compliance engineering. And today we would like to talk to you. We would like to introduce you the topic hazardous area classification, which I do believe by most of you who are, if I may say, professional on your side, on your field. We are willing to present how we do it and how it can be done and how it should be done. So what is hazardous area classification? Hazardous area classification is nothing else simple, the basis of explosion protection, basis of HAZLOC, because we have to identify, we have to locate and imagine, picture, describe the area where the explosive atmosphere is present or can be expected to present. Okay, so that's not like a continuous being there. And hazardous area can be gas, mist, dust, hybrid mixtures, so many topics. Certainly, hazardous area industries are endless. Okay, today I cannot say any industry without partially or fully being hazardous. Okay, look at the printing industries, the hospitals, aircraft, armies. Okay, shotguns powders, refineries. Okay, marine ships. Or the today trendy topics like hydrogen fuels, LNG, the green powers, ammonia, all these belong to hazardous areas, including woodworking areas, sugar refineries, or even the car industry. Okay, all if you look at the metal treatments, etc., with the coatings, they belong to hazardous industries, and there the basis of design, the basis of operation and maintenance shall be the hazardous area classification. The key message. In any hazardous environment, we have to protect the workers. The workers have to be able to assess the hazardous areas and have to be able to leave, okay, the hazardous areas, which means we have to keep up the safe level of working, we have to keep up the safe level of maintenance, and it means the hazardous area has to be identified at the early stage of operation. Okay, at the early stage of design, because when it happens in a later stage, then we will certainly suffer. There will be delays. There will be, let me say, unwanted happenings, which we are not willing to face. Okay, so that's something we need to do. In order to identify IEC 60050, okay, this is the international electrotechnical vocabulary. The part 426 give us a definition. An area, I already told you, which explosive atmosphere is present can be expected to present in quantities such that special precautions for the construction, installation, and use of equipment are required. Are required means mandatory, essential. In Europe, back in Europe, okay, where I'm coming from, this is driven by the regulation, okay? In other countries, it might be regulation, might be standard, might be a local decree, but doesn't matter. It's the basis of explosion protection, the basis of safe operation, okay? And what is also very important, if there is any change, okay? If any change occur, a process, operation, this HAC, the hazardous area classification, has to be updated. Okay, so this is an ongoing process. Let me say, back in Europe, every 3 years you have to validate your hazardous area classification. But certainly, if in the meantime there was a change, you had to be. The HAC defines the, let me say, the volume. Okay, the time being there, and it's always a 3D model, okay, because there is a top down, an elevation, okay, it's not like a flat surface. So we receive hazard classification from various vendors, various designer companies, and then most of the time we just receive a drawing. From a drawing, you cannot identify simply just the hazard classification. So, which means there's always a need for a complete bunch of documentation in order to have the full picture. What is the HAC? Okay, how is the HAC created? How has the HAC been created 5 years ago, 3 years ago? Okay, so how we come to this point, how we do hazard classification, this is what we would like to show to you. Therefore, I invited one of our specialists, Mr. Mátyás, who will show you, okay, using our tool, how it can be done, okay? And certainly this is not the only way of to be done, but this is a possible way of. That's why we created with our partner in Italy together the Aragas software, where we would like to go into details how it works and what it can be done. Certainly, all these softwares, okay, this is a long years development. The basis is the IEC standards, okay, the NFPA standards, okay, the NEC standards, because that's very important, because our let me say, imagination was to create a software which can be used internationally, which can be give you the solution internationally. Okay, and let us not forget, what is the outcome, the output of a hazard classification? Always the EPL, okay, always the EPL. What kind of installations can be done? But not only the EPL is the outcome, because the drawing, the 3D model will give you the extent of the, and that will, the extent of the zone, extent of the various zones, because there might be various zones, and it will give you also the, let me say, the set of tools which can be applied there, work safety, fire safety. So all other disciplines are strongly influenced and, let me say, are driven by the HAC. So that's why it's a very important topic. And once again, we believe that the compliance to various standards and guidelines, that's essential. That has to happen, and it has to, let me say, work that way. We just listed, see below, all the different standards we are working into. Okay, so that was my short introduction. Once again, feel free to ask, and as soon Mátyás will finish his part, we will come back just for a short. We already received few questions. I would like to give you a detailed inside view. And end of the day, please note there will be a questionnaire you might receive, and if you answer it and you can successfully complete it, you will receive a certificate of attendance from this webinar, which might be very important because you can show it up like a refreshment course, whatever. Okay, so we hope to let me say that you will enjoy this tour, let me say, together. And Mátyás, that's your turn.
Thank you very much, Árpád. Just let me share my screen. Yes. Have you seen my screen?
Yes.
Thank you.
Thank you.
Good morning, everyone. My name is Mátyás Dalnoki. It's a great honor for me to present here for you. At first, I would like to say that English is not my native language and not most of yours native language. So if something is not clear, please don't hesitate to stop me and ask back. We have got a very short time to check out the Aragas software. The software can be installed for 2.0 and 3.0 version. The difference between these two versions is that the 2.0 based on the IEC 6079-10-1 2015 version. The 3.0 is based on the 2020 version of the standard. On my laptop, installed the 2.0 version, but the lookings and the interface is the same. Only the calculation methods and the coefficients and figures has been changed for the 3.0 versions. I prepared a simple model project for today for you. Let's check it out. We have got a painting factory. If you close your eyes and imagine a very old, very big hall with artificial ventilation, that could be. In this painting factory, we have got a raw material storage place, mixers which made by barrels. So it's simple barrel mixers. It's an important point for the evaporation. We have got simple pumps, nothing special, not double sealed, not magnetic gearboxes, and just a simple pumps. We have got a very simple product downloading place where the downloading for the packaging happens. And we have got a temporary production storage tanks with vent pipe into the hole. It's a very important point because the ventilation goes into the hole, not outside across the roof. Let me just say that it's very similar one of our existing projects, so it's not a fantasy, these two areas is used for raw material storage and product storage, simple storaging, nothing else. So it's a very, very, very simple working hall with a very simple painting factory process. The mixer surface is, let's say, 1 square meter. The whole production hall surface is 600 square meters. The long side will be 30 meters, for example. The short side will be 20 meters, for example. And we have got artificial ventilation from top to down. So the exhaustion is installed around on the downside. The inlet comes from the top. And the ventilation rate is 10 per hour. So very shortly, this is the project. And now let's say the software. What we can choose at first, that we can open the database. There is an inbuilt database into the software, which contains more than 300 different substances. At first, we can choose a new project. Just click new. That's all. We can name this project. We can fill a lot of different data about the project. Who is our customer? Where would it be? And so on, so on. Let's say this is the Pink Pony project. Yesterday evening, when I prepared for this today morning meeting, my youngest daughter, not new, close. Yes, close is the enter button now. My daughter watched the My Little Pony series, so this is why I named it the Pink Pony project, because it's burned in my brain forever.
That's the problem of home office, yes?
Yeah. And the evening work, my boss, I just said.
Okay.
So now, if you check the standard method starting with the emission sources parameters, but the software started with the environmental data, because you will see that during the project you can build up different kind of sources of release parallelly, and the software can use the same environmental data that you given it first. That's the reason why it started with this. We can change the ventilation temp or the environment from open to closed. If we say it's open, we can give the efficiency of the ventilation and so on. It's same the software. In this case, we can choose from the software, from the standard table, the different kind of situation what we have. But now we have that artificial ventilation. It's a closed room. In case of closed room, you can choose general artificial, local artificial ventilation, or natural ventilation if you have that opening places only. Now we have that a simple artificial ventilation, nothing more. So in this case, you can see that if you have that general artificial and local artificial, or general artificial and natural, you can handle it together. You can manage it together. If you have got only artificial ventilation, as in my imagination in this project, I just left it to 0 and it won't calculate it. Now we can say something about our building. The long side will be 30 meters. The short side will be 20 meters. The height would be 6 meters. The filling coefficient can be 5% or whatever. You can calculate.
Mátyás, let me allow to just jump in and give a few details, okay? Because that's, I do believe, very important, that hazardous area classification is part of design. So what Mátyás is describing you is one of our projects we just recently did to give you a real feeling how it goes. And without details, okay, without design details, hazardous area classification cannot be precise, okay? And these informations, either you do it with a site visit, okay, like a brainstorming, like a kickoff meeting, or you get it as per the user requirement specification, okay? So that's very important. And again, hazardous area classification is part of design. So it requires a very detailed and precise cooperation between the engineer who does the classification and the site people as well.
Thank you. So now we can give the ventilation data, the artificial ventilation data. As I said, it's 10 times per hour, and we have to give the data in cubic meter per second. So now if we say that it's roughly 3,400 cubic meter, the fill volume space, and we can say that 10 times per hour, so it's 34,000 cubic meter per hour. It's roughly 9.5, 9.4 cubic meter per second. After that, the software calculates the air velocity in meter per second like the standard one. So
that's also very important to mention, sorry, that we just simply follow with all engineering knowledge included what is described, what methodology is given in the standard.
Yes, it's absolutely follow the standard methodology. Now, if we don't calculate any natural ventilation, we could, but I don't want to take your time with this because we have got a very limited time for this now. We can say it would be enough. Let's close it. And we finished the environment parameters. Now we have to give the substance. Of course, in a painting factory, there are a lot of different substances. Now, just for in this case, I choose the acetone. Sorry. The software contains more than 300 different material parameters filled out with the needed data from the software, from the standard, sorry.
And also very important to mention that you can give your own substance, okay, your own material, and you can also search the database with the cache number. So there are various opportunities to come to the data.
Here in the tools menu, you can give more substance if something is missing, if you have got some special substance. In this case, you have to give the all needed data. But if you would like to calculate by the software method, you have to give all needed data at all. So it's nothing new. Just you can put here needed data, needed materials. And if you have got mixtures, and if you know the data about the mixtures, you can give some mixtures data also. Okay, so we have got the environmental and the substance data. So let's say about the source of release. If you remember this, we have got different source of releases. We have got an evaporation from the mixer. We have got primary grade of release from the prompt. We have got evaporation from the downloading place, and we have got evaporation from the product temporary storage tank's vent pipe. So now 1, 2, 3, 4 different kind of sources release that we have got in this small project. So let's start from the first.
And let us be honest, that's very usual that in one project you have many possible multiple source of releases. Okay, so you cannot just proceed with one.
And there is a very important point at this step, that every emission source can emit into the same hole with the same ventilation effect. So if we handle this all emission sources into the same project, the background concentration will be calculated by the software parallelly after every source of relation source of release what we give into the software. No, the physical substance is liquid, and the ventilation velocity is given from the environment. We don't change here because it's not really needed. But what we have to change is the evaporative property of the material, because if you check in case of acetone, yes, this database what we usually use. In the case of acetone, the vapor pressure in 30 degree, it's roughly 380 hectopascal, which means in a normal case, the whole mass of the solvent won't be evaporated by 100% until the dynamic state, dynamic equal state, it will evaporated. What did I say just before? Sorry, 3.8% of the existing solvent will evaporate, and after that, the dynamic state won't let evaporate more. So that is a very critical point when you use the software. We can calculate by fugitive emission, but not now. Please let me calculate it later. Now,
all these definitions you can find in the IEC standard. Okay, So what
Yes.
we're using here, because lack of time, we are not willing to go into detail. This is not, let me say, a substitution of a training, okay, of IECX 02 training for hazardous classification. It's more about the tool, okay?
Yeah. So now we are ready to calculate the grade of the release. Here, because the physical state is liquid, the software let us to choose what kind of releases what we have. What kind of release what we have. There are different kind of release here. What is mentioned with the different kind of equals. Now we choose the most simply is when we get a evaporating surface and the evaporation is diluted by the artificial ventilation. If you click new, the calculating table shows us these details. At first, we have to choose the grade of the release. It's an open barrel. So now we have to decide, is it a continuous grade of release or a primary grade of release? In an average case, if it's not a pool, I would say it would be a primary grade of release because there is not a continuous mixing process there. The mixing process is a batch process. And after the mixing has been ready, all mass of the liquid will be pumped from the mixer. So it's a repeatedly process, periodically process, but not a continuously process in this case. We have got the surface, as I said, is 0.1 square meter. We can give the number of the releases. And this is the critical point, because now here, if you remember, we have got 6 releases in a row, 6 mixers in a row. So we calculate the evaporation 1. Oh, sorry. But in our hall, there is 6, what we have got. The temperature of the substance can be chosen. It's a closed hall. Normally, we could say it can be 25 Celsius degree. Ambient temperature can be 30 or also can be 25. Let me choose 30 because now the summers are very hot. Safety factor. Remember that now it's the 2.0 software version based on the 2015 software standard version. In the 2020 standard version, sorry, the safety factor has deleted from the equation, but the 2020 standard version says that, okay, we deleted the safety factor, but the hazardous area classification person has to shall to define some kind of safety factor somewhere in the process, which is a very unpolite, very unpolite mark in the standard.
That makes it, let us be honest, a unique way of understanding, and it makes pretty much based on the expertise of the professional who is doing the design. And certainly the 2015 edition with the K factor 1 to 5, it gave us kind of limitation, and it was in the calculation. But now the 2020, you need to give it by yourself. So, and many people forget it doing the design, doing the hazard cell classification. So that's also very important that the software will make you remember that.
And in the 3.0 version of the software, the safety factor still in the software. So they didn't delete it, the developers, but you can choose to give the number of 1. So in this case, it won't change anything in your calculation. Now I would say it would be 0.5. Vapor pressure of the substances came from the substance properties which installed into the software and so on. Mean velocity given from the environmental sheet what we given earlier, and ventilation efficiency can be given here. Let's say 3. Now we ask the software to calculate, and there is something here what you can see. What we can see is now if we focus only the evaporation of this 6 mixer, which defined as a primary grade of release, in this ventilation diluted from zone 1 to zone 2. You can here see the sheet from the standard. There is a very short zone, short distance, and the degree of dilution now is high. You can see here, but we hasn't finished yet. The main data are given here. The software said that now you are in high dilution, and if you would be in medium dilution, you will see that the software gives the point of the low and the high meter per second dilution air points from this releasing. Okay, but we hasn't finished yet because we have got other source of releases. Let's say new. Let's say pumps. Sorry, I forgot the number.
3.9.
Yeah. Close.
So for all releases, you need to do the same procedure, and that's very important. Otherwise, there's another option. You calculate the whole room as one, but in that case, there might be a very expensive solution. So it's always a matter of understanding, a matter of question, which way you go, source of release methodology or the room as one. Okay, here we go, the source of release, which is, let me say, more convenient and more the everyday life.
Yeah. So now we have got a different kind of releases here because the source of release is a seal. It's a simple mechanical seal of a pump. This is also a primary grade of release, and we can give the relative pressure, which let's say 3 bar, for example. Discharge coefficient can be chosen and can be given by the standard 0.75 as usual, what we can say. The temperature of the substance, let me say 30 degrees. Here we can increase it to 0.9 because in normal case we don't wait releases from a mechanical seal, but it can be. The whole procession.
So sorry, Mátyás. One point. Even the -10 says that you have to consider the aging.
Yes.
Okay.
Yes.
The aging, the seals, the aging, the gaskets, the aging of the technology. Okay, and especially environments like with high ambient temperature, like in the Middle East. Okay, aging is a very obvious topic
Absolutely.
to happen. Okay, so here you need to consider while you are doing the design, while you are doing the hazard specification, this topic very seriously.
Yeah, absolutely. You're absolutely right. Now, there is a very interesting point of the software. You can see different kind of parameters of the emissions source size given in the standard. This is the standard table, but we have got additional possibilities given in a guide. It's an Italian guide. CEI is the Italian Standardization Association, and they published a very useful guide what we can use, because it's possible by the standard to use national standard or appropriate industrial guides, and it could be. So we have got much more possibilities to choose the needed data than in the standard. Now we have got a pipe. Here you can see it's the given number and the possibilities if you have got more came from the standard. Now we have got a simple case, just let's say 0.25 square millimeters. The main air velocity is our artificial velocity, is given from the environment as usual. We can say the efficiency main factor, just B3 as the previous case. Please calculate something and what we have got. Now the dilution is also in high. So until this point we are good. You can see here the background concentration is less than the critical concentration. So we are in a good case. So near this, around this pump, now we have got half meter zone 2, and the figures here now the same, almost the same. If you remember, in the previous case, this point was very near to this axis. Now, because we have, oh, sorry, I forgot to set the number of the releases. If you forget something, you can go back and now set here, because we have got 6 of it, not just one. Number of the release here. Yes, that's what I forgot. Calculate, please.
Which has a strong influence on the extent.
Yeah.
Yeah, they will be added together.
Yeah, the main parameter hasn't changed.
Mátyás, there is a question. What indicates the dilution?
Sorry?
What indicates the dilution?
The dilution is calculated as high now, but what I would like to show to you previously, that when we check the first case, we have got a very small amount of the release characteristic. Now it's a higher release characteristic, and the background concentration, when it calculated and compared to the critical concentration, is added now. So if we if we start to calculate our next grade of release, maybe we can go out from the high dilution effect to the medium dilution effect. It's always calculate the software parallelly at the background. If we put more and more grade of releases in one project with the same environment, the background concentration comparison with the critical concentration is always updated at the background. That's a very, very important thing, because if you do the calculations manually, it's hard to do. The software can do it very quickly and continuously updated. So the next grade of release,
we have 4 altogether in that project.
Yeah, is the joints. If you check, we have got mixers here, pumps here, temporary tanks here. So it must be some pipes with ring joints, for example. And the product downloading areas here. So we have to calculate with some joints.
And we shall not forget, only the welded joints shall be considered as fully tight. Okay, so when there is no welding, it means then there is an emission.
And now I would like to speak about the fugitive emission. We don't know by heart how many joints what we have, but let's say a number, for example, not so much 50. We have got some equipments jointed in the pipes. We have got pumps, we have got tanks, and so on. Let's say 50. We can choose different kind of emission points. Flange or thread type piping accessories is the most common. So we say would be new 50 pieces.
Which is not much. Okay, so
yeah,
let us be honest.
Not much.
In a normal site, there might be hundreds, okay, thousands.
Yeah.
And people are normally only talking about the technology, and the pipes goes forgotten, okay? And then whenever what happens, any incident, normally it comes out that the reason, the emission, was coming from a joint.
So this fugitive emission due to the joints is happen in background. Now we calculate the real effect of a ring type joint seal. We say it's a secondary. Relative pressure is also 3 bar. Yeah.
Normally the joints are considered to be secondary grade of release.
Now we have to choose ring type joint connection. Sorry, here.
Sorry, just let me say, if it goes to primary, it means lack of maintenance, the aging, etc., etc. Okay, so normally the design stage says it's secondary.
Yeah. Let's change it to 0.9. Okay, main air ventilation came from the environment. Efficiency would be 3 now, as before.
And change the number of releases.
Yeah. No, in this case now, because the ICX and the ATEX point of view that in one time we have to calculate only with one independent failure. In the fugitive emission point, I set the 50 ring type joint connection just with a very small amount of releases. But now we can say there would be only one independent failure at one time. So we don't need to say that there will be 3 or 4 or 5 injured sealings in the ring type joint connection. In the previous cases, I said that, okay, we have got primary grade of releases, which could give release time to time, regularly. But now we need a failure to give a release. So that's the reason why I only calculate with one in one time. But these ring types, the joint connection, are calculated in the fugitive emission. In this case, in 10 times air change, we are in good at this situation also, but the background concentration is continuously increasing. If you checked in the previous cases, this background concentration is increasing because we have got more and more grade of releases in the same hole with the same ventilation.
And if you look at the type of zone is negligible extent, yeah. And no EPL has been defined, but certainly that shall be the decision of the engineering team that even in negligible extent, you define an EPL, okay? So that's again the way of engineering decision.
So now we have got 4 more evaporative points. The temporary storage tanks ventilation pipe, the end of the ventilation pipe, which is inside, located inside near the tank. Next source of release. Yeah, in this case, we haven't got fugitive emission. Great. But now we have got a different situation because we have got a tank which is closed. Only this vent pipe gives the emission source. So now we have got a pool ventilation, pool evaporation of non-size without ventilation air contacts, because this drawing is not so good, not helps too much in this case. But it would help if you think that if you read down the situation, and we can choose or we can choose the container of variable section, and that would be in our cases now.
Mátyás, there was a question.
Yeah?
If the joints, the location of the joints, do matter or not?
Here not, because we are in the same room, so
that's a closed environment.
Sorry.
That's
yeah, it's not in an open environment. We are in a room, and in this room we have got only one ventilation, not separated by walls, not separated by local exhaustion systems and so on. It's a primary grade of release.
And let me be precise, Mátyás, let me be precise, that still in the software, even if they do not matter, you can locate them, okay, with the software.
Yes, of course.
You can position them, okay, as you like. So to be precise and to be able to follow up any changes, okay. But still, what Mátyás said, is the main point here, that we have one ventilation. Okay, so and that will be the, let me say, the protection layer for our operation.
I just give some data about the tank, the vessel. I would say it would be a 2 meter high tank with a 0.3 meter of the ventilation pipe length, and the surface of the evaporation in the tank is would be 2 square meter, and the surface of the vent pipe emission point is 0.1 square meter. And we have got 4 from this.
Mátyás, we have few minutes left.
Yeah. Sorry, I saw. Ventilation and evaporation factor, and that's all. Close. We have got a very short distance zone 2 around the pipe, and it's still high. The degree of dilution is still high, so the due to the all emission sources, the background concentration is still less than the critical concentration, which means this 10 times air change in this room is very efficient. So now we would have only one more point, but I ran out of time, sorry, because we don't speak about the product downloading and packaging place, but now by this you can imagine how does it works. So now at the end we can say that we don't need to classify the whole room as hazardous, because we checked all of different kind of source of releases, and we would say after the end that the background concentration is still less than the critical concentration. So now we can focus only the emission source.
Sorry, Mátyás, attendees are saying, let us go into details. Okay, so they do not hurry. If you agree, then let us make it complete.
Okay. One more emission source what we have left.
And certainly what is important, with all the emission sources, you can define various substances, okay? So it might give a difference, because in one technology room, there might be various substances, okay? So that's also an option that you can define, but there are more in one technology than you have to define for all separately, okay?
So now, in case of the downloading, we have got several cans which parallelly filled with these paintings, and the solvents can evaporate from the can until it would be closed by manually somewhere in the room. So we would say parallelly 6 or 8 cans can evaporate until the closing process during the filling, because it's a row, you can imagine.
And there's always a fight with all these barrels and cans, because people say, they love to say that they are tight, fully tight. That's correct, as long as they arrive and the operation opens it, okay? And as soon as they open it, it's already evaporating, okay? Without any limitation. And whenever they close it again, it not will be fully tight, even if the manufacturer says, okay? So then there will be a continuous evaporation, okay? As you said, Mátyás set it to primary. That's the case.
Yes, I set the temperatures and the emission data. Just let me say that the 0.2 square meter is the surface of the can. it could be whatever. I said that we have got 8 can, which can be evaporated at the same time, and we have got primary grade of release. In several cases, if you have got some interlocks, not in this point, but if you have got a pressure or a flow meter interlock in case of a tank filling process, which could close the filling points, the source point and the end point in case of a tank filling. If you have got any source of leakage, you can set the time of the emission. So basically, the standard method manage all emission sources as an endless emissions. Now in the software we can give only a time frame. How long can it be until some interlocks or someone react and stop the emissions?
That can be strongly defined by the HACC, okay? And what is also important, please do not forget the maintenance procedure, cleaning procedure, okay? Because that's part of evaporation, okay? Whenever the technology is closed and running, there might be no emission, okay? But cleaning, maintenance, it only gives the opportunity to do it that way.
So now in our case, maybe you checked that the background concentration has risen 1.5 something to 1.7, not point, sorry, 0. Lot of 0, 1.5 something to 1.7 something. So the calculation happened for the background concentration, but it's still less than the critical concentration. Of course, it depends on the solvent. It depends on the number of the fugitive emission point. It depends on a lot of things. But we can say now that this 10 times dilution factor, the 10 times air change rate in this hole can dilute efficiently the whole emission sources.
But I hope that you see that if you are increasing these values, you can lower the extent. Okay, so depending when you do the hazard classification, okay, as part of design, and I would strongly recommend to do it at the basic stages, okay, because in that way, while you are doing your primary hazard classification, you can already set the parameters accordingly, according to your best interest. Certainly, for later on, the operational team has to maintain all these parameters. So again, it comes to the competence, explosion protection, EX personal competence we are talking about, whatever it is, okay, whatever scheme you follow, but it all relates to the same topology that you have to have understanding what is the HAC about.
Now I just would like to show you that if we wouldn't have 10 times air change rate, only 5 times air change rate, and I reduce the airspeed for all, it would be checked that here you can say now it appears zone 2 only for the second recalculation, because if we wouldn't have 10 times, only 5 times, it means that we reach the critical concentration earlier, maybe can reach. So now
Mátyás, there is a question. How is the temperature class of the equipment is calculated?
The temperature class.
The temperature of the equipment.
Yeah, the temperature class is given by the material properties. If you check, as I mentioned, we use Gastis database to know anything about the material properties. In the Gastis database is given the ignition temperature of the material, and it's also given the temperature class from this and from the IEC 6079-14 equipment selection standard. So the temperature class came from here. And it's also installed in the software material properties.
Database, yep.
The database, yes.
So that's very important. The temperature class of the installation shall be related, the minimum requirement I'm talking about, shall be related always to the substance in the environment, okay? And when we have multiple, okay, certainly you have to go straight forward to the more dangerous one, okay?
Yeah. As I see, with the 5 times air rate change, we still good. So it means that we don't need to classify the whole room as hazardous area. In this case, we has to classify the equipment's near environment as a hazardous.
So like in that case, in your drawing, you can make a bubble.
Yeah.
A 3D bubble around your equipment, and you don't need to classify. Let me say in Europe, in certain countries, there is a 40% regulation. If the complete surface or the complete volume exceeds the 40% of it, okay, I mean, I'm talking about the extent of the hazardous area, the whole room has to be certified, okay? But outer of Europe, this regulation doesn't exist, or this good engineering practice doesn't exist. But certainly, let me say, if we do the classification, we follow that because that gives a very applicable approach in general.
And at the end, you can prepare a printout from the software. It's a Word document. And it contains the calculations, the equations, the figures, and a lot of more, because this software is able to prepare risk analysis also, like a complete explosion protection document. But this risk analysis part I haven't shown to you because we have a very short time gap for this presentation. Just I would like to show the printout, how does it looks like. Come on, work.
That's very important to say. The software itself is running on your PC. Okay, so it's not a web-based solution. We are not collecting data, etc., etc. It's on your PC, on your storage system, and it can be installed on your PC only. And whenever you reinstall it, you need to reinstall the software as well. Okay, but that's possible. And what is important in that case, the software, the outcome, the result of the software gives you a very detailed description, detailed view of your hazardous area understanding, okay, with all the textures from the standard, okay, so there's no additional texting. And that was our intention, to be very straightforward here and to help your work. Okay, that's also important. Certainly, the software can be used like a service package. Okay, but it can be used by individuals, by teams as well, and to make it happen. This data you can source it from the software if you give it there, but you can rewrite it. Okay, and don't forget. The hazardous area classification is a legal document. The legal document has to be signed and has to be revalidated time to time that we still comply with it, and has to be followed very strongly, okay? And that, once again, that's a legal requirement because, again, all other disciplines they are designed based on the your risk assessment, based on your hazardous area classification, and based on the results of your hazardous area classification.
Yeah, and now I just very shortly at the end, you can see here the printout, the Word document from the software. there is the main project data what we gave at the first point. There are a lot of regulatory references in the background, which is listed, which kind of standards, guides used behind the calculations. It's a legal terms and definitions, formal terms and definitions, the zones definitions, and so on. Environmental data. We can add picture in the software, and in this picture happens here. Now I haven't given I didn't give a picture. Sorry. If we would have natural ventilation with these openings, it would be given here. But now we wouldn't have natural ventilation. The fugitive emission is listed here. The main parameters of the hazardous material, which is given in the standard also. If we would prepare ignition source analysis, the result would print it here, but now I missed and didn't show it to you.
But let us be honest, you need to prepare, okay? So that's part of the work based on the hazardous area classification, okay? So that's like a follow-up activity for any kind of project, okay? It doesn't mean if it's a service garage, a service station, or it's a refinery, or it's an H2 technology.
Yes, if you prepare explosion protection documentation, it shall contains ignition source analysis independently of the subject of the project. So general data about the emission source, the picture of the emission, the equations here, a summarization table with the results, the graphs. Where are my figures? Here. Here are the figures, the dilution time, the other factors if it needed, the shape of the zone. If you select, you can select the shape of the zone. If there is any possibility to modify the hazardous area, it's written here, but this reduction process has to be done manually after the hazardous area classification. The second and the summarization. Here it's the software give requirements for the equipment selection based on the properties of the material. This would be the risk analysis part, summarization, and the second emission source, and the force, and the until the end. So the calculation and the figures and the equation are shown here in the report documentation. You can edit it, it's a Word. So basically that's all what I would like to show you today.
Mátyás, I thank you, and I take back the picture, okay?
Of course.
Just let us do some conclusions, okay? And let me say it was an honor to have you here, because I do believe that was like a very important topic. Just to give you a few inside
Thank you. It was an honor to
details.
me also. Thank you.
Don't run away. We have Aradust as well, which is more like for dust hazardous areas. There is a separate software with the same methodology and the same property database, etc. So that's also a possible option. And now, if you allow me, I would like to go into a few questions which we received in the meantime while we have been doing this development and the use of the software. And you have seen, you already got the answers for most of it, because Mátyás and myself, we talked about. But you can add properties also by yourself, okay? And then there was a question about the purchasing the software. Yes, it can be purchased, but additional updates are with an annual fee. All these shall be sent to you in a separate email. And certainly, as you have seen, the Aragas is an engineering tool, okay? So I would say there is a competence of explosion protection is required to use it well. Certainly, to play around, yes, you can do, but there's an engineering knowledge and expertise is strongly required. And yes, if I'm an end user, I would strongly recommend to make my own hazard serial classification, because I have to maintain it. I'm aware about the changes, okay? So I have to have an influence to do like that, and that's an important topic. And again, there is no notice period, etc. The software is running, software is working. We update it regularly as per good engineering practice, as per standard requirements. Like you see, Mátyás was introducing the 2.0 version, which is based on, there was a question about this, with all the CEI standards. For the 2015 version, but there is a 2020 version as well. And but again, in many countries, in many regions, in many sites, the older version was the basis of and still the basis of hazard classification. So that's it. There is a possibility for training. Certainly, that's part of the package. And UAE, yes, we are there. So and for the region, but even we do supply clients in America, in Australasia, so in many countries, and also in Italy. We are there with our partner with the university. So that's also very important. Yes, reproduction of the HAC design, existing one, is possible, but that's controversial, let me say. On the other side, let us not forget, we have to have a fully detailed information about how the HAC was done, okay? Because it can be very conservative way, conservative approach, or more like with additional protective layers. So we have to have a clear understanding how it was done, how it has been done. No limitations, but certainly let us not forget is limited to one computer. Okay, so I do believe one computer can be used by one person at a time. So that's it. And again, that's not a software, sorry, a server-based solution. So we do not store anything. Aragas itself is not a drawing. Okay. It's not an AutoCAD based. So the AutoCAD drawing itself, you have to do it by your own. And that's the question, what tools you have, because there might be different softwares as well, but it can be easily done. Okay, so that's a very important topic. Sure. We can do it outdoor, indoor. You have seen artificial ventilation, natural ventilation. That's part of it. And this is very important. We can verify the existing design, and you need to verify it, okay, as per part of the operational team, or as per part of that the hazard classification has been outdated. Okay, so that's the topic. And for sure, CFDs can support the classification. That's a very important topic. And if it's needed, a training or not, you shall decide. Okay, I'm not saying no, but let me say the more the requirement that you have to show up your intelligence, you have to show up your competence, and it can be verified. For example, I would say, let me be honest, for example, with the IECX 002 training, okay, which is let me say very dedicated for. What type of facilities? All kind of facilities. Okay, so there are no limitations. More is the limitation, the knowledge of the one who is doing the design. Okay, because I do believe we are not like multi-talented people. Okay, so we have to have a strong understanding of the technology. And yes, Aragas can be used with other standards as well, because there is always an interface and a cross-linking section. If you see the NFPA, the EI, the API, that's all works together. Okay, so that's very important. Like I told you, after the afternoon session, you will receive an email with access link to our online verification of competence tool. This is we developed as well. And there you will have 10 questions, multiple choice. And if you do it well, and I do believe you will do it well, because you are all, I know most of you in person, that you can do it well. So you will receive a certificate of attendance. This we would like to make it more valued, okay, even by you, this being here and make it happen. Okay, so again, it was our pleasure to welcome you here. Here you have our email address for this webinar, aragasindex.ae. And once again, explosion protection and let me say, all this related engineering is strongly based on the hazardous area classification. How you do the hazardous area classification is your topic, but you have to have one, and you have to have a valid one. And this validation is related to the technology, functionality, applied explosion protection methodologies, and time as well. Okay, so this all you need to define in your Site EX policy, we used to say, and it shall work accordingly. So I wish you best of luck, and see you later on. Hope to meet you in person. We will send you a summary email, okay, to all of you. Whenever, if you do not receive, please check your spam box. And wish you the best of luck with the assessment. Okay, you will receive an access link after the afternoon session. Don't forget it. And you have like a 1 week time frame to answer it. Okay, so again, thank you being here. Mátyás, thanks for your excellent summary, and hope to welcome you. And there was an idea from some of you just to make it some kind of chat group or Teams link. We will keep it up, this team link, and invite others as well, or make it possible to join. So here we can talk, and maybe we can come up with some good engineering practices to make it realized. With all the questions raised by you during the session or after the session, please feel free to ask. We will come back to you. I already received a few hints, WhatsApp and Teams chat as well. We will collect it, we will answer it, and once again, that's our intention, to make it for you very visual how Aragas and Aradas work. So we are planning to have an Aradas session later on as well in a few weeks' time. You are most welcome there as well. Okay, so see you then, and cheers. Okay, thank you, bye-bye.